Introduction. The concept of SWOT analysis was developed in the 1960s by Albert Humphrey at the Stanford Research Institute during a study aimed at understanding why corporate planning often failed. The method has since evolved into a fundamental tool used across various sectors for strategic planning and decision-making. The four components of SWOT analysis describe strength, weakness, opportunities, and threat.
The descriptive statistics for independent variable 1 summarize the responses of 60 participants across 4 items: S. Trade policies, W. Trade policies, O. Trade policies, and T. Trade policies. Scores range from 1.00 to 5.00 with means between 3.40 and 3.95, indicating moderately positive ratings. Standard deviations range from 0.85 to 0.98, showing fairly consistent responses. The descriptive statistics for independent variable 2 summarize responses from 60 participants across 4 items, which is S exchange rate, W exchange rate, O exchange rate, and T exchange rate. The scores range from 1.00 to 5.00 with W exchange rate having the highest mean, which is 3.88, and S exchange rate is the lowest, which is 3.60. The standard deviations range from 0.88 to 0.96, showing consistent ratings. The descriptive statistics for independent variable 3 summarize responses from 60 participants across 4 items, which is S global market, W global market, O global market, and T global market. The scores range from 2.00 to 5.00, which means between 3.70 and 4.8 and 4.18. The standard deviations range from 0.75 to 0.93, showing consistent responses clustered around the mean. Next, the descriptive statistic for dependent variable dV, which is dV1, dV2, dV3, and dV4, show responses from 60 participants ranging from 1.00 to 5.00. The average scores are similar, with dV3 having the highest mean, which is 3.80, and dV2 having the lowest mean, which is 3.60. The standard deviations range from 1.00 to 1.07, indicating some diversity in ratings but not significant dispersion.
For the dependent variables dV1, dV2, dV3, and dV4, normality tests show p-values below 0.05, indicating that the items significantly deviate from normal distribution. The reliability analysis revealed moderate internal consistency with a Cronbach alpha of 0.683, suggesting that the items are related but not highly reliable. The same Cronbach alpha value was observed for standardized items, confirming consistent reliability across all items. For independent variable 1, both of Kolmogorov-Smirnov and Shapiro-Wilk tests indicated that all 4 items, S trade policies, W trade policies, O trade policies, and T trade policies, significantly deviate from normality with p-values less than 0.05. Regarding reliability, the Cronbach alpha for the scale consisting of 4 items was 0.683, indicating moderate internal consistency but not a high level of reliability. For independent variable 2, S exchange rate, W exchange rate, O exchange rate, and T exchange rate, the Kolmogorov-Smirnov and Shapiro-Wilk tests bring out significant deviation from normality in all 4 items, as shown by p-values below 0.05. Thus, it is risky to say that the items are normally distributed. The Cronbach alpha for the scale formed by the 4 items is 0.697, reflecting a moderate internal consistency. While this indicates that the items do share some relations, it does not stand strong internal consistency. In the case of independent variable 3, S global market, W global market, O global market, and T global market, the Kolmogorov-Smirnov and Shapiro-Wilk normality test showed that all the 4 items were significantly deviating from normal distribution because in each case, the p-value was below 0.05. It means data for these items are not normally distributed. The reliability properties of the scale formed by these four are good. Cronbach alpha is 0.746. That means the items are strongly related to each other.
The table represents the results of regression analysis. There are three independent variables, SWOT-TP, SWOT-ER, and SWOT-GM, influence a dependent variables, DV. The key columns represent B, unstandardized coefficient, shows how much the dependent variables, DV, change when each independent variables increase by 1 unit. STD error indicates how much variability exists in the coefficient estimates. Beta, standardized coefficient, shows the relative importance of each variables in predicting the dependent variables. T-test, if each variable significantly contributes to the predicting the DV. P-values, if this value is less than 0.5, then the variable has a significant effect. None of the independent variables here, SWOT-TP, SWOT-ER, nor SWOT-GM, are significant because all the p-values are greater than 0.5. Tolerance and VIF. Check for multicollinearity overlap between predictors. Since VIF values are all below 10, multicollinearity is not a concern. And lastly, for the constant, the value of dV when all independent variables are 0. So here the constant is 1.762 and is significant to P equal to 0.020. This table summarizes how well the regression model predicts the dependent variables, dV. R squared 0.115. This means that only 11.5% of the variation in the dependent variable is explained by the independent variables. SWOT-GM, SWOT-ER, and SWOT-TP. This is a low value, indicating the model does not explain much. Second, adjusted R squared 0.088. Adjusted R squared adjusts for the number of the predictors in the model. It's slightly lower than the R squared because the predictors don't contribute much. Third is standard errors of the estimate, 0.72315. This shows the average distance that the observed values fall from the predicted value. A lower value would indicate better fit. Fourth is ANOVA table. There are F tests, 2.434. Test whether the overall model is a significant p-value equal to 0.074. Since this value is greater than 0.5, the model is not statistically significant. This means the predictors SWOT-GM, SWOT-TP, and SWOT-ER do not collectively predict the dependent variable well. And lastly is Durbin-Watson 1.754. Checks for autocorrelation, relationship between errors. A value close to 2 indicates no autocorrelation, which is acceptable here. Collinearity happens when two or more predictors variable in a regression model are very similar to each other. This can make it hard to tell which predictor is really affecting the outcome. Eigenvalue. This number shows how much information each dimension or predictor group contributes. High numbers mean more unique information. Lower number can signal problems. Condition index. This number helps us understand the potential of collinearity. If it's high, like above 15, it suggests that there may be issues with the predictors being too similar. Variance proportion. This percentage shows how much of each predictor's information is linked to the dimensions. High percentage mean that those predictors are likely related to each other. In my data, dimension 1 has a good eigenvalue, which is 3.957, and a condition index of 1, indicating no problem. Dimension 2, 3, 4 have a lower eigenvalues and higher condition indices, 14.225, 16.146, and 20.506, suggesting potential collinearity issues. For example, in dimension 2, SWOT-ER is linked to 85% of the variance, meaning it's very similar to other predictors.
In conclusion, the study examines how trade policies, exchange rates, and global markets affect international business, with respondents giving moderately positive and consistent ratings. The data shows deviation from normality P less than 0.05, and reliability analysis indicates moderate internal consistency with Cronbach alpha 0.683 to 0.746. The regression results reveal positive effects of the independent variables, with SWOT-GM having the strongest influence, but the model explains limited variance, which is R squared equal to 0.115. The multi-collinearity suggests redundancy among predictors, highlighting the need for additional variables and improved analysis methods.